Hello, everyone. I'm Saph. Like you said, Don Lee's son. Going to talk to you about 3D printing. I'm sure a lot of you have heard about it. I'm sure a lot of you have kids, grandkids, uncles, and whatever. You know, this is pretty widespread at this point. So if you haven't heard about it, hopefully this will give you a little bit of an intro. I'm going to talk primarily about 2 different methods. One of them is going to be a lot more interesting for y'all here because I've made a number of things for my dad for radio stuff, which I have examples here. We'll talk about them as we get into the presentation. We can also pass them around if you want to get a look and feel for them. So, can you guys see me over here? I'd rather stand over here. So about me a little bit. 3D printing hobbyist. I've been doing this for 8 years now, I think. Right as the whole consumer grade stuff started coming out. As I'll talk about a little bit later, it's been out since like the 70s or something like that. So new tech, only in that consumer grade stuff is new. I printed dozens of functional objects, like I said, radio cases and stuff like that, wire winders, guy pole mounts. Is that what you call them?
Guy wire
mounts. Yeah.
Yes.
Costumes. Hundreds upon hundreds of little miniature models, so like Dungeons and Dragons kind of models. And I've gone through 5 different printers at this point. So I don't know, I've got a little bit of experience, certainly not a professional though. Also 3D designer, I've worked with SolidWorks and also worked with a design application called Rhino. So that's me at Comic-Con. I 3D printed the costume, had to do sewing and stuff like that, but give you an idea of just the widespread stuff you can do with this tech. So I'm going to talk to you about the common printers, like the 2 different types. We give you a brief history of them, kind of just probably skirt over that a little bit. The types of printers, I'll give a description. I'll have examples. I have a couple of animations so you can get a feel for how each of them works. The 2 that we'll be talking about are very different in their implementation and their execution, and then what they actually manufacture. We'll talk about setup, cleanup, and cost in case you are interested. This just gives you a very ballpark kind of feel for what it takes to get into this hobby. We'll talk about computer-aided design. So if you want to actually make your own files, design your own stuff as opposed to just take things other people have designed and print them. And then, questions throughout the whole time. So feel free to interrupt if you have questions. Same with online, obviously. So let's get into it. So what are the most common types of printers? There are probably dozens of actual types of printers, but the 2 most common ones are called extrusion, up in the top left. This uses a filament type spool. Like I said, we'll get into it. Stereolithography, also known as SLA or resin, up at the top right. This uses like a liquid pool of resin. And then your bottom left is direct metal laser sintering, DMLS, or metal. This would be what you use in industry. They use this in aerospace. They use this, I don't think it's in cars yet, but I think several of the F-35 components are manufactured using that. So we'll only talk about the first 2 though. Oh, there's a lot of words. Okay, so we'll talk about extrusion first. I really probably should have put what extrusion is first. So you know what, we'll come back to this. So
is there a screen to be shared? A presentation to be seen?
Oh yeah, there should be. Are you guys
being shared now?
Oops.
Was being shared. Were you not seeing it before?
You had your schedule up there before.
Yeah, I know. I don't know what. Peter's freaking out here. Hang on a minute, guys.
That's a nice wide angle lens. Okay.
Yeah. Oh yeah, it's Logitech. It's really nice. That's why I use it.
Thanks.
Yeah, sorry about that, Bob. I don't know why it's not. For some reason, my menu bar decided to come back as well. So I don't know why it's.
Do I need to not make it full screen?
No, it should still make a full screen.
Okay.
It's just a matter of why it's not showing the share button anymore.
Well, at least we know that Bob didn't fall asleep yet.
So yeah, it should be sharing.
Your dad showed.
There we go.
So it take a while. They could see.
That's true.
Okay. Do you see it now, Bob?
It's coming up.
Awesome.
There it is. Thanks.
There you go. Let's try this again. Take two.
Okay. So before we get into the history, I should tell you what extrusion is so you understand it. Extrusion is your most common type of 3D printer. This is what most people are going to think of when you say 3D printing. So what it does, and you can see this in the GIF or on the side, it'll incrementally lay down plastic into thin lines that will ultimately culminate in a layer. So this is a little bit faster than animation. Sorry, I didn't have time to film my printer doing it. Plus, you wouldn't actually get a perspective on what it does and what it looks like because this is very slow. That rocket, for example, it's probably like a 6-hour print if I had to guess. Depends on your settings, of course. So what this looks like is a spool of plastic wire or filament feeds into the extruder and provide the printing material. So like up in the top left, you got your different colors of filaments. You can build your different colors of objects. So for example, I don't know what this is.
We'll talk about it later.
Yeah, okay. Yeah. Different colors, different materials, nothing fancy. So with this diagram, you can see a little bit better that it lays down individual lines, both on the external and then the internal. So a nozzle will take the filament and melt it and slowly lay down the little individual lines. I believe I have a little bit more detail on that, including a little bit of the technical details about how an extruder physically works. But the extruder head will be set at about 200 degrees Celsius. 3D prints are surprisingly low melting point. 200 degrees Celsius sounds like a lot, but you leave them in the car, they're going to deform, they're going to melt. The way this actually builds the print, we'll go back to the GIF, is you can see there are 4 different motors actually acting here. You have your X and Y moving forward and back on the bed, and you have your Z axis pulling up, moving the nozzle, this centerpiece, up with it. So the coordination of all of these different motors, and then your 4th motor is actually pushing the filament into the extruder head. All of these work together in order to create the print. We'll talk about how it knows how to do all of that later as well with the software. Okay, here's a diagram about this. This is your nozzle. So this is the part that on this GIF is actually, you can see it dead center of the green. This is the part that actually puts out the material. So you can see over in the left, sorry guys on the online, can't really see what I'm pointing at. You have your nozzle on the far left. This is a series of components that all work together. You're going to have, we're going to start with this. Let's start at the bottom and move up. So you actually have your nozzle head. The nozzle head has, specific diameter to it, internal. You adjust the different nozzles you actually use for different printing purposes. We're not going to go into that. That's more advanced stuff. But what you'll have is an insulation material around that nozzle. So as the nozzle is heated up by a heater, you'll actually start to melt the plastic, but it can get so hot that it will propagate through the entire system and actually burn out your motors if you're not careful. This is all prefab when you buy any printer. If you really are into the hobby, you can make this yourself. Don't recommend it, at least until you want to really dive deep. As I mentioned, there is a heater, the PTC heater on this diagram, the pink. This heater will put the heat through the metal copper alloy heat spreader to bring it down into an even spread temperature around the nozzle. So this ensures that the plastic is fully melted around the nozzle evenly. If you weren't to do that, you would actually see filament coming out at weird angles, not the full extrusion amount. Sorry, not normally this anxious. Don't know why. Weird. And you'd also see gunking happen. So as the material flows out, it creates imperfect ripples that would start to oscillate, create weaker prints, put holes in your prints, things like that. I think that's all we need to. And then up at the top where it says cold end, the gray, that's really your radiator. So this entire section below the radiator can get very hot, even if you have that insulation. ultimately, that's what dissipates the energy into the air. There is a fan that usually attaches to that radiator as well. So you actually get a forced flow of air to cool it down. Otherwise, if that fan breaks, and I can talk from experience on this one, you're going to burn out every single motor on your printer. It happened to me on a 72-hour print. I think I was at hour 60 of the print, and then everything broke. It even broke the print because one of the motors failed and it fell back down onto the print, melted half the print. So it was a good time. Let's talk about the software. So this is actually how the 3D printer knows how to build this thing, because obviously a 3D printer looks at a 3D object and says, I don't know what that is. It has no clue what it's making. So what you'll do is you take 3D models and convert them into individual motor commands. These are called G codes for you computer nerds out there. 3D objects, in case you're not familiar, are just 3D pictures on the computer. It's all they are, nothing fancy. Computer-aided design people will create these. So for example, this boat up here, it's called a benchy. It's usually the first thing to print, just to test your settings of your printer. That is a file you find online. You just download the file, import it into this slicer, and it'll begin to do its magic in order to actually allow you to print. So like I mentioned previously, the slicer will have to break this into commands. You have your STL, which is that solid object. The slicer will take the print, and just like you're cutting cheese, cut small little layers. And that is dependent on the settings you have, how much material you're extruding per second, various things like that. How fast you want to print is really the big one. And then it will take each of those slices, convert it into individual movements of the nozzle head. So as you saw back, we'll go back. Oops. In this diagram, you have the individual movements of the head. So it's just moving, putting lines down, and each of those lines have thickness. It's obviously not, a mathematical line. So in aggregate, when you take all these different lines, all these different layers, it'll form the 3D model as an approximation of it. So perfectly smooth lines like this do not, they're very difficult to make using current technologies of moving X and Y axes back and forth. Obviously, you start getting into higher resolution stuff, higher quality stuff, and it gets better, but there'll always be some minor imperfection with 3D printing. Here's an example of the codes that the computer gets. All it is the command that it wants. I know this is super small for you guys in the room, but this is like, okay, take the extruder, start turning it on, start putting out the material. All it's saying is motor, keep going. And these other ones say, hey, other motor, X motor, move this much, Y motor, move this much, and Z motor, move this much. That is what a G command is. So the software I use, for example, is Simplify 3D. We'll talk about what you might want if you ever get into this hobby. Super simple, very user-friendly at this point. When it first came out 10 years ago, it was still pretty new and pretty much in its infancy from a consumer standpoint. So it's a little bit more difficult. Nowadays, all you do is you slap it in, you tell it, hey, anything that's overhanging, so like you can see the windows on this boat, or like the very tip of the bow overhang, and it'll put support material underneath. So this is how you make things that are weirdly shaped. So for example, this helmet, if you imagine this on a printer bed, you can see that there is a big gap underneath. So the printer would not be able to put filament into open space. So if you imagine the thing going back and forth and extruding lines, but you're doing it, 6 inches above the air, it's just going to drop it onto the ground and you're going to ruin your printer. So instead, it'll put little tiny pillars that it'll build in addition to the actual print. So when this was printed, it was oriented like this, and there was a box of support material up at the top of it. It doesn't have to have perfect overhang. So you can see, like, for example, the little overhang on the top of the roof doesn't need support material. So they're able to just barely put it maybe 45 degrees over. And because the plastic melts from one layer onto the other, or one line onto the other, there's a little bit of adhesion that happens because of it. I realize there's a lot of details I didn't put into this presentation. So let's talk a little bit about extrusion examples. This is, like I said, this is going to be the type of thing you're most interested in from a radio standpoint. So for example, with this attenuator, is that what it was?
No, it's just an IC chip switch. So basically what this is when I was doing WinLink or FT8, I had two different radios. One was an Anytone, one was my Kenwood HF rig, and my sound card was a Signal Link. And if you wanted to switch between the 2-meter rig and the HF rig, you'd have to go into the sound card, quote unquote sound card box, and switch out the chip. And I got tired of doing that. And so what this is it just switches between chips. And you see a ribbon cable plug there. So a ribbon cable came out that one end, and you see the switch on the other end.
So I'm passing it around so you can get a feel for what the actual material feels like. This is relatively thick of a print. I did it so you can actually put little screw holes in it. So he's able to screw this down. I believe he just opened it up so you can see visually what's going on inside.
And no comments about my PC board there. I know it's pretty arcane and novice, but anyway, so he also helped me with printing out that PC board that's inside.
So one of the neat things with the filament style prints is they are very robust. You can get different materials that make them even more robust. Like you'll normally start with PLA. Oh gosh, what is that? I'm not even going to try. I'm going to get it wrong. Or ABS plastic are usually your two starter ones. So the structural integrity of 3D prints is going to be less than your classic injection mold, simply because the plastic is laid down in layers. So if you put too much force on it, it will break the layers, and that's going to be your point of failure. You can see the little, you might not be able to see quite because it's a little bit small, but as I pass it around, you can see the layers individually that are laid down. If you put the box together and you look at it from a horizontal angle, you can kind of see the individual layers. If you catch it in the light just right, you can also see them. Next one.
Was a motherboard made separately?
I'm sorry?
Was a motherboard made separately?
Yeah. So 3D printers, generally, consumer grade 3D printers only work with one material at a time. I'm almost always just one feed at a time. So while the motherboard was made by Don, the plastic that was actually printed was made by me. One thing I forgot to mention, as you notice, the hardware, you can interface a lot of different hardware with this stuff. So when I designed this using the software, I put little holes in so we could put the taps in, put a hole in for the plug, thank you, as well as a hole for the switch. And then using screws, we're able to screw in, you can screw a little bit into plastic into the hole, but if you have anything structural, you have to put some of these individual taps or things. So very flexible in what you're able to do with it. It's not just plastic. This is the next example. So this is what I was talking about. This is not an actual photo. That is AI generated. Didn't have any photos of his antenna tower. I'll pass these around as well.
I use this for my POTA mast. I have a 33-foot telescoping mast for POTA.
That's why you're so strong.
No, we can carry that around.
And as well as a wire wrapper. So I believe this is how he actually stores the guy wire. No, the antenna wire.
Well, the round one is for the guide wires.
Oh, okay. I had no idea what I was making. He just told me what he needed.
And then those others, the end pieces are for the end piece of the dipole antenna. So it's like that's the insulator between the row and the antenna wire itself.
So there's like what, 9 of those or something?
Of the guide rings?
Yeah, guide rings.
Actually, I think they're only like 3.
Okay.
You printed
a whole bunch of variants.
9
that must
of
be
the
like
very
9
diameters, but I think I only ended up using 3.
Okay. So what are some other extrusion examples? Just random things you can do with this. Up in the top left, you have concrete laying down via 3D printer. So some companies are trying to build buildings out of 3D printed concrete. It makes for very rapid, very modular, and completely custom designed buildings on the cheap. Doesn't matter if your design is a like Monopoly style house or if it's a completely independently designed structure. all that matters is how much time it takes to put down the material. You got wire guides and the yellow at the top of the center of the screen. Just snap wires in, it'll hold it. Not all these are me. Somebody made a soda holder for their fridge. This one's actually me. It doesn't look like anything, but what this was is I had a company where you had little RC tanks. They're about a foot long, and they'd shoot lasers at each other. And so I used IR in order to encode different messages of different types of rounds that were being shot. And then it was all hooked up wirelessly via a PlayStation 2 controller. So that's actually the PlayStation 2 controller's box for the Arduino that I used for this. I had a lot of fun with that.
That was cool.
My dad helped me quite a bit. We went to the Adams County Fairgrounds during their big county fair and set up a booth there. Surprisingly went very well, considering it was very much a prototype.
Yeah.
3D printed armor, like I alluded to earlier, that's where the helmet's from. So this is all done via filament. Functional pipes, I actually have one of these in my house, in my plumbing. So using ABS plastic, you generally don't want to use PLA. It doesn't last very long from a structure standpoint. It's still pretty good. But you can actually use it for plumbing. You do have to coat the interior because with those layers, it's not guaranteed to be waterproof. So generally putting some type of coating like, Flex Seal or whatever in the center will actually make it waterproof. Another Arduino cover, things to hold your cans. And I made a gift for somebody, just a little potted plant turtle. So what do you need for an extrusion setup? You need an extrusion printer. That's going to be the main cost. Gosh, they range from $150 to a couple $1,000 at this point. Really just depends on what you're trying to do with it. The filament rolls, generally about $20 each for about a kilo. You're going to need a computer for the slicer. You need a stable surface for the printer, because as the printer moves around, if the surface is moving with it, you're going to create discrepancy in the motor position relative to the bed. You're going to need a ventilated and temperature controlled area. I don't ventilate mine. It's not too hazardous, but I don't recommend doing what I do. I just don't have the space to actually put ventilation in. The temperature control is extremely important, as well as dust control. If you are working in, say, a shop, like a woodworking shop, the dust is going to destroy your print, because the dust will get on the bed and get on the print itself, and then you won't be able to have that layer of adhesion. It'll also jam up the printer as you're trying to put wood through something that only burns at 200 Celsius. You'll need space for maintenance equipment. You'll need a trash can, because you got to throw away that support material or failed prints. Okay, let's talk about the second type, stereolithography, better known as resin in the hobbyist community. What will happen is it'll set a pool of resin above like a little TV that shoots out UV LED. It's a UV LED screen. What will happen is, as this head, or I guess that's the best word for it, platform. I don't actually know the word. The platform will sit very close down to the TV when you first start. When I say very close, I mean generally about 0.01 millimeters or so. Depends on what resolution you're using. And it'll slowly move the bed up, as you can see in the animation. And as it does that, the UV LCD screen will flash an image up. It'll melt, or it'll cure the resin against the previous layer of the resin, and it'll pull up, slowly, iteratively building your print. So you can see the Eiffel Tower being pulled out of the material. That's a little timer on it. That's about 6 minutes of print. So the resin print is extremely fast compared to filament print. Talked about that.
Okay, I could follow the filament.
Mm-hmm.
But that, where's the magic take place? It's below the surface.
Yeah, let me see if I have a better picture. So right underneath, so this is a tray full of resin, and underneath the bottom of this tray is a very, very thin, clear, what is it? I don't remember.
It's like an LCD screen almost. It just goes black or clear.
Yeah, there's just a thin film in the tray to hold the resin, so you're dumping it right onto the TV. But it's otherwise just a little TV screen about the size of the tray. So that's what sits on top of it, and it'll take images. The screen will display images for a couple seconds each, and that will semi-cure the resin onto it. and pull it up. Does that make sense?
Right.
I have an image right here, actually. So this is an example of one of those images. So I'm printing a Hydra for Dungeons and Dragons. So we'll talk about the support material in a second, but you can see this image vaguely corresponds to everything that's happening on that layer of the Hydra. So this is the Hydra is being pulled. The little squares in the bottom are what started the print. So the little squares in the bottom are going to have adhesion to the platform. So that'll be the very first layers that are made. And slowly the Hydra is being pulled out of that. So this layer right here, this is the technically upside down orientation. This is this layer is what's exposed to the LCD screen at that point. Does that make it a little more clear?
So the LCD screen, is it hot?
No, it is literally just emitting UV light.
So it's just using UV to cure the resin.
Yes. And we'll use UV later as well to actually fully cure the resin, but it just semi-cures it so it stays solid.
There's a pull button instead of a push button.
Yes, exactly. Everyone on the same page with that? Cool. It'll also generate support material. So with the filament head, like I said, it moves back and forth, puts down support material. With this, those are part of the image. So that slice of the Hydra head is just these blobs in the center of the black image. That's the actual model. And all these little white dots all around are these little pillars that have been built up in order to support the material. Once again, you can't make this exist in 3D space just with a sudden layer or a stitched platform and nothing will build. So you have to have these little support materials to pull it up.
So is resin faster than the extrusion?
Resin is lightning fast compared to extrusion. We'll get into the benefits of cons in a minute, but the short of it is resin is very weak compared to filament extrusion. So if you're making functional parts of resin, not going to last very long, but they're great for little things like this. I have a little tank that I use for wargaming. This came out of the resin printer. All I had to do was pull the support materials off, throw it in the bath to wash it and cure it. It was 2 minutes of post-processing. And this tank probably printed in, 20 minutes, something like that. And I printed 20 of these at the same time. So your unit cost of time is extraordinarily low for resin because if you imagine if we push this Eiffel Tower over to the side and put another one there, we could have this image done multiple times. And so as long as your model is small enough, you can tessellate the model throughout the image and generate as many as you want. And it doesn't have to be the same model. You need various types of models all at the same time. So like with the Hydra, I could have slapped my tank right there. I'll pass the little tank around. So you can see if you look really closely at this one, the layer lines are very small. So that's another benefit. You get really high fidelity models printed out of it. I don't recommend it for anything radio. You're going to need stronger pieces for that. But if you like Dungeons and Dragons or wargaming or just painting little miniatures for dioramas or whatever, this is fantastic. We doing okay on time? I haven't been paying attention to time.
Oh, you're good. Okay, that's time. Great.
So the resin post process, here you have that platform that was, for example, holding the Eiffel Tower, now it's holding a dog. You remove this from the platform. So as you saw with the Hydra, there was the little square box, and this is just holding it onto the bed. So you remove it from the platform, you pull the supports apart. So you can see here in image 2, this guy's got a heart, I believe it looks like. Yeah. And he just grabs that material and pulls it off. Filament printers, one of the downsides is you actually have to cut it off. Means there's a lot more cleanup, means there's rougher edges where you have support material. But for resin, it's almost perfect. Like if you look at that tank, you would have to know what you're looking at in order to see the little dots that held it together. I believe it's on the front. It's either the front plate or the back plate of the tank. I don't remember which. Uh-oh. Oh, there we go. Words aren't there, but the bottom left image, you can see you put it into a bath. So this is chemically based instead of, PLA is a chemical, but instead of heat based, this is chemical based. So there's going to be a little bit of resin left over on it. So it's going to have like this really gunky kind of feel to it of uncured resin sticking to the cured resin. So all you do is you run it through a bath. I actually have a little automated machine that does this. It does it extremely well. Usually that bath is made out of acetone. 99% acetone is usually the best option. Very flammable, so you do have to be very careful with it. No smoking.
You want to ventilate too.
Yes, this is one of those ones that ventilating does matter a lot, or at the very least, keeping it fully contained. The machine I have, you just open it up, you put it in, you close it, and as it actually spins, it spins around an impeller that cleans the material. So I usually let it sit for a minute so I'm not getting all of this vapor into the room. But yes, ventilation is important here. And then finally, you put it into a little UV cure. So all this is more powerful LEDs emitting UV. You make sure it gets all angles. So usually there's a little turntable underneath. So for this phone booth, TARDIS from Doctor Who. So phone booth.
It's bigger on the inside, Steve.
Yeah.
All this does is this spins around, the UV lights finish the cure. And so that's how you get that little tank's worth of quality and cleanliness. Here's some resin examples. Here's a painted one. So the resin is strong enough where you can put paint down. It doesn't chemically react with much stuff. Anything you're going to use from a hobbyist standpoint, it does not react with. So for example, up in the top left, that's 150 some odd D&D models I printed and painted. Was doing that for a campaign I was running. A lot of fun. The center one is more of a functional resin. Like I said, generally speaking, you don't want to use it, but you can see lots of little tiny detailed parts in there are excellent for filament print or resin printing because you can more cleanly get all of those nice little tiny edges. I didn't print that one. I don't know where that comes from. Yeah, I'm not going to speculate what that is. Top right, just more of the painted models, a little bit closer resolution. You can see, like on the dinosaurs, you can even see individual scales on them. Bottom left, some people have been using it as kind of a more prototypey for everyday objects. So like a bendable, squishable water bottle. Medicine, they're actually starting to use it quite a bit. So I don't know if your dentist has ever 3D printed anything for you, but here's an example. They'll take the cast they actually used, 3D print a mold, and then cast into the mold. And once again, with the rabbit over here, that's exactly what they did. They resin cast the mold and then just whatever material that is, filled it in.
You know, at your brother-in-law's dental office, they actually 3D print crowns there.
Mm-hmm. I bet that's also coupled with a CNC machine as well.
I think so.
Do subtractive manufacturing on top of that to get the holes better. But yeah, it's being used in medicine quite a bit.
But it's not plastic.
No. And I mean, they're using probably not plastic resin like I'm using, some high value material. Yeah. I'm sure it went through 20 years of testing in order to get there.
So you don't get cancer in the mouth because it's in plastic.
Yeah. Yep. Resin setup. This is a little bit more involved. That's the biggest downside to all of this, aside from the structural stability. You need your resin printer, of course. You need a resin cleaner and cure. So some people just use a little bath and they shake it in bath for a couple minutes. I actually have a little machine that you put the isopropyl alcohol in, spins, and that cleans it. And then you need that cure, that UV box. Like I said, isopropyl alcohol. You're going to need a computer as well. Just like previously, you need a slicer. So that's how that hydro is being generated. You need space for lids and tools, including your personal protective gear. You should be wearing a mask and definitely need to be wearing gloves when you handle this stuff. It isn't inherently toxic. You can also get plant-based stuff, so it's a lot less toxic, but exposure to it is not great. So usually using disposable gloves. I use paper towels as well. Sometimes use a mask. I'm pretty lazy about it, frankly. I'm probably going to get cancer. You're going to need the resin. You'll need a strainer and funnel. So if a print fails, you need to run it through a strainer because there could be little microscopic pieces of resin that was cured but didn't adhere to anything. So you just dump it through a funnel with a filter and your resin's good to go again. You're going to need spare empty bottles for that process, and you'll need a trash can. So the big question, filament versus resin. I've been alluding to this as we've gone. Your filament is much stronger, takes up less space because you don't need 5 different paraphernalias. There are no chemicals beyond PLA. Simpler post-process, but more involved in terms of getting detail out. The pieces can sustain damage. I wore that helmet for 3 days at Comic-Con a couple weeks ago and got bumped constantly. Had to take it off, take it on, put it down. It fell on the ground at one point, but it all held up. If that was made out of resin, it would have shattered the instant it hit the ground. The prints are cheaper. They're cheaper in that if you're making the same model, the filament is a lot cheaper than resin is. But because these are used for different processes, that tank is probably 5 cents. That helmet is probably $30. Either way, like I didn't have to make on the design of it. I didn't have to make it, so $30 is pretty cheap for what that is. And then the radio boxes, $5 each probably is what I made them for. The resin is higher detail. You can print in bulk. You can rapid print. I think I printed the 150 models in probably 24 hours. It's quieter because all it is one motor moving and it's not moving rapidly. And it's more reliable overall. Filament has a lot of downsides in terms of maintenance. All right, we'll talk about CAD very briefly. The engineers in the room probably are aware what SolidWorks is. It's just a mathematical way to design stuff. You put in some numbers, it generates a file, it creates that solid computer 3D file. So like, for example, there's a rendering of a pipe. Real quick in the bottom, like you can do really cheap stuff if you really want to. This comes default on Windows, it's called 3D Builder. All I did was slap a few shapes in there, it took me 30 seconds. And if I wanted to print it, I could get this little weird cylindrical box thing.
Cannon.
Yeah, it kind of looks like a little cannon. Different file. I'm sorry. Yeah, I didn't think about that. I just learned slap.
So many more.
Yeah.
Yeah.
Some wheels on it.
See, that would have been smart. I could have actually printed it and brought it. Wasn't thinking ahead. Yeah, so different file types, doesn't matter. You load, just like before, you load them into the slicer. Variety of programs, some are free, some are paid. I think the personal versions of SolidWorks is like $100 a year. Sounds like a lot, but SolidWorks is super valuable, but there are a lot of free ones, like I mentioned, 3D Builder. They'll require different levels of skill and functionality. I don't recommend diving into the $1,000 version of whatever you're going to build. There's going to be a million tools you don't need. Plenty of places to learn. This is a pretty big community at this point. So YouTube, Reddit, Discord. If you want, you can email me as well. I'm more than happy to help you get set up and started. I can help you choose materials you want. I can help you budget properly or even set up. So this is posted online, I believe, so you can always grab my email there.
Yeah, it will be.
Okay. Any questions?
How many total printers do you have that you can tinker with?
I have 2 right now.
Okay.
So I went, first one I got, I actually built. It came in a kit, fully assembled it. It was okay, but it was only like $150. Had to wire up all of the electronics, had to attach the motors, get the drive belt set up. The biggest one I had was right before all of this took off. It's like $2,000. Wasn't nearly as good as the one I have right now, which I got for like $600. So technology just moves on. And then the one that's been printing all those little resin models, that one's my favorite. I don't know how much it was. I don't remember. It wasn't a ton. But that's the one I use primarily at this point. My filament printer gathers dust most of the time.
The club actually had a 3D printer donated to us.
Oh, do you know what type?
Run him. Spear.
Okay.
That's the name of the company. I can never get to work. Our vice chair actually has it in his house right now and got it to work. So he filament. Okay. So he prints wire holders for us with the call sign on it.
So you're familiar with
Well,
this?
I have a bunch that we've given away at Amfest, stuff like that.
Nice. Yeah, super nice to have them available, kind of thing. Everyone becomes your friends, kind of like owning a pickup truck.
Yeah.
How much of the stuff, what proportion of stuff do you download the designs versus creating your own with the CAD?
Oh, that's a great question. Yeah. Majority of what I print at this point, I get for free or for like a few bucks. on a couple different websites. Should probably put that out there. Thingiverse, My New Factory. I can send that out listed and send out an email if anyone cares. So from a ratio standpoint, probably 95% of what I build is taken from other people. But that's because if I'm designing it, it's usually something custom, like the helmet or like the radio boxes, with all the little miniatures. I don't have the patience to design those.
Thingiverse is cool.
Okay.
I look at STL files all the time, but have radio stuff just for see what somebody's designed.
Yeah, I know there are like wire wrappers. There's a couple.
There's holders for HT. People made call signs.
This game.
I have a 3% call sign at home too. So
Can I pass this around or no?
Yeah.
I don't know what this is.
What this is this is my QRP rig. This is for my backpack station. It's what I use on summer field day. That one is a kit from QRP Labs, and that does 160 meters to 10 meters. Single sideband CW digital, does almost everything. 3 to 5 watts. But the gray parts are protecting the dials and the connectors on both sides, because put it in a backpack, it's going to take some beating.
Yeah. Or swallow some dust.
Sorry.
Or swallow some dust.
Yeah.
Swallowing some dust.
Oh, yeah, exactly.
And I won't pass this one around because it's very heavy and there's a loose. He has it here. I decided to make a print box that would hold together with no screws or anything like that. And so I got rid of all my little tabs. So I said, all right, forget it. I'll make it functional. So I made little pillars in each of the boxes. They interface together. The keyer is held in place. And when it's all put together, it holds the keyer in place. I don't recommend throwing it because the box could pop open and damage the keyer. You'd also break the print. You'd probably be okay with the keyer, but
This particular one I don't think, I think it was for Coda. And that's why you built that box for me, so it would protect my venture keyer. It's pretty expensive keyer. I have a lot.
You don't carry that heavy base with you?
Yeah. Actually, you know what? This field day, I did take that with me. And I decided I'm not going to do that again. Because that's pretty heavy on top of everything else I'm carrying. So it's been great. That 5% that he doesn't buy, it's usually my stuff.
yeah. At this point, aside from the costume, I think that's the last thing I printed in the last 2 years. That wasn't his stuff.
Oh,
You can also get a little custom, so I put his call sign in each of the little boxes.
Yeah, and by the way, these gray pieces we actually got for free off of the QRP Labs forum. People put that out there. I just shipped him the files and he loaded it up and printed. Everything else he designed. We had a couple iterations, and how requirements go. Your user doesn't really know what the requirements are until it's already done. He's patient. Yeah, exactly. Yeah, he's real patient.
So how long did the helmet take to print?
As I alluded to, the print really depends on the print quality. So when I say quality, it's how thick you want your layers to be. The thicker the layers, the faster the whole thing will print. The thinner the layers, the smoother it's all going to come out. That helmet, I did put epoxy down on it and sand it and everything. But the print probably took 72 hours, and I was printing at kind of a coarse resolutions. That was with the filament printer.
So that helmet's multiple parts, or one part?
It is 2 parts.
Okay.
It was supposed to be 1 part, so I was supposed to join the faceplate against the actual back of the actual helmet. But in this one specific case, I added a little bit of magic to it, make it get my head in out because it was too small. And I wasn't going to reprint it because I had 2 weeks left. So you got to leave a margin in case the print fails. Anything else?
I'm trying to see a lot of that happened when I was messing with a burger that didn't work properly.
Yeah.
So I don't know.
It's always the fun part of films.
Any suggestions for optimizing your filament prints? Like you're getting relatively low quality, even though the layer thickness is relatively thin, you're getting some issues out of it.
So there are a million things that can go wrong. If you're asking a specific question, I have to look at it to get a feel. The most common problems is a belt is loose. So you'd have to tighten your belt. You would notice that because the layers are slightly shifted or relative to where they should be, or there's some like zigzagging effect happening. Another one would be your filament head is jamming. So sometimes if the filament's really poor quality, there'll be pieces that aren't like true PLA. They'll just be like little rocks effectively that'll jam your filament. So if your print is happening and then it just suddenly stops, and the printer keeps going, or there's little strands coming off of it, that's 9 times out of 10 my problem. We can talk after if you want, extra details, whatever. Anything else? Sorry, that ran a lot longer than I thought.
Anybody online got a question?
Good here.
All right, thank you all.
Thank you.
Thanks.
Yeah, appreciate it. Good job. All right. All right. Thank you again. Appreciate the presentation. That was interesting. So like I said, the club does have a 3D printer. Mike's, our vice chair, has it at his place. If you need something 3D printed, let us know. We can see if I can get it done for you. Like I said, the wire things are really great, especially for long wires. I use it for my some of my ground plane wires, brown wires, stuff like that. So it works out really nice, especially with like the over recoil. I have those ground planes. Anybody got any questions, comments, concerns? Nothing? All right, as I said, next month, Junior, the expedition presentation. If you're interested in that, please come out. Should be really good. I want to say her name's Olivia. She's out of Sea Springs, so she'll probably do it over Zoom with her presentation. But I did meet her last weekend at the Mile High DX Association's picnic, which they're trying to build that club back up again. So if you're into DXing, participate with them. We're getting going again as a club. I think it's $25 a year, and they don't have repeaters or anything like that. The funds from that club goes to help support expeditions. Usually anywhere between a $200 to $400 to $500 donation to expeditions like, Galapagos or some little island out in the middle of nowhere that nobody's ever heard of, in the Gulf of Americas or whatever. Expeditions are not cheap. I know there's some that individuals pay up to $20,000 to $50,000 just to go with. Yeah, because some of these places you can't get there except by boat. So you got to go rent a boat that can haul all your equipment. Then you got to have an experienced crew that you're paying for. You got to get there. I mean, it all adds up.
That's chump change for most of us.
Oh, so you can afford that. I'm still working on.
I just heard volunteer to pay.
There you go.
The expedition.
For everybody.
Yeah, and keep an eye online. There is a. I do have expeditions listed on our website on the calendar. So if you want to try to make contact, please do so. Sometimes propagation is good. Sometimes propagation is crappy. You never know, it's a crapshoot, especially now. So, but as always, keep your faces to the mics. Get on the air. Start talking. Tell your friends, family about us. The other thing that I'm pushing, not really pushing, but promoting is, and everybody think about this as well. As a club, we've always kind of promoted ham radio in general. Not a bad thing. I'm rethinking personally myself. I'm pushing radio in general, radio service. So, for example, I've got a gentleman who homeschools his kids. I told him, and it's interested in amateur radio. I said, try this first. Go get your GMRS license. Covers the entire family, $35 for 10 years, no tests. Get some small radios, send your kids to the park, tell them to leave their cell phones at home. Things like that to get people on the air. Because like Brian and Kat has said multiple times, people get their license, radios just sit there. They get mic frank and whatever. Get them started. Even if they just a couple walkie-talkies do FRS, get them on the air, get them talking, and then they'll say, hey, this is cool. I want to talk to somebody in Japan. Go get your ticket. I want to talk to a satellite. Go get your ticket. Then you promote the next steps. And I think that's something in general would just help everybody. Because the GMRS group here in the Front Range, which has a really cool repeater system, that's usually more active than ours, 85% of those folks are hands already. So it's just a natural progression. So think about that, and when you're talking to folks, and if they got kind of scared off when you mentioned amateur radio, go with the other ones. Promote radio service in general, because even if you have a handheld, and say you're in a cul-de-sac somewhere, you can't get out of your cul-de-sac, at least you can maybe contact somebody on FRS or GMRS. Get them on the air. It's the way I'm kind of promoting it and doing it. And I think it's just a different way of looking at it. And then when people get interested, that's when they go, oh, this is cool. How do I bounce my signal off the moon or whatever? And go from there. So kind of think about that when you're talking about radio in general. Not that I'm trying to take away from amateur radio, because don't get me wrong, but we need to get more people on the gateway.
It's the gateway to get people into
It's a gateway, yeah, exactly. Yeah. Exactly. Get them started and then give them the good stuff. Anybody got any questions, comments?
I have a little field day brag.
Yeah,
So, I go to Rabbit Mountain with this route here, 3 watts. My first contact was 1,800 miles.
Nice, congratulations.
Yeah. And it's just a sloper to the top, from top of the tree down to the ground. So,
Which area?
the eagle went, yeah. And it's really cool because a deer came right probably 15 yards by him. It was this you're the only one out there. That's pretty cool too. But yeah, no, I had several that were over 1,000 miles away on 3 watts.
Very good.
So
You never see that?
yeah, those were CW. I only got 2 FT8s that my computer died.
Well, FTA wasn't as busy this year as in past years. I haven't told our numbers yet. I still have to do that. I apologize. I know we didn't do as many as I would have liked to done, but I feel that our field day was successful in the fact that we were able to set up like we wanted to. We planned ahead. We knew exactly what we were going to do, and we made it happen whether people showed up or not. There's a couple of nice pictures in the Longmont Sun-Times. There's a couple of infamous people. One is sitting in this room right here.
Well, we had a bunch of people there too.
Yeah, and we had a bunch of people show up. The visitors list had 40 people. So I unfortunately was not able to partake on Saturday because I had a wedding up in Blackhawk, which was interesting in itself because it was a Renaissance wedding. So people dressed up in Renaissance. The groom cried more than the bride did. But I came back. We didn't have any sunburns this year. We had a safety officer, which did a great job. Thank you, Steve, taking on that role. Things were roped off. We had flags in there. I mean, this looked like a professional setup. And I think a lot of people pitched in. A lot of people pitched in, but they saw that. I saw that we know what we're doing, right? It's all been documented now. We have IAPs. We're going to go through them. With that said, I'm looking for volunteers for next year to run field day. So if you're interested in running it, 80% of the work's done. Just come in some volunteers, all that's in there, add additional notes or whatever, and go from there. We did go 4A this year. I think we're going to go less next year because we had a lot of empty radios. I think more of a 3A with the go-to station, and then if Dick wants to do the 6 meters, even the 6 minutes, those are both free radios. So they don't count anyways. We did have some new folks come out and try to get on the air. Things like that. Our dipoles were great. We're going to look at that for next year, maybe get them higher. That's part of the problem, just not high enough. So until nighttime came, we really didn't have good propagation. When night came, propagation got better, of course. We didn't, height didn't really matter at that point. During the day, it kind of does. Generator ran great. It was nice and quiet. A lot of people didn't know it was there. Things like that. So it was a very successful event, and I want to thank everybody who helped, participated, volunteered. So thank you all. I know Bob Smith, I think his name was listed in the paper. He gave some comments. I don't think his picture was in there, but
Thank goodness.
your picture was in everything too, Bob. I think yours is in there and Steve's in there.
That was the best looking guys.
And then there's a couple of shots with Aki in the background. And then Aki is in the background of you guys too. So
I actually had plans on coming here from Rabbit Mountain, but on my way down, I actually got dehydrated. So I needed a safety officer in my place.
there.
And actually, when I got home that night, My wife had to call the paramedics
Oh, really?
because I started cramping really bad. Yeah. No, yeah, so.
Well, that's what,
You should have.
that's why we got a lot of water. I actually went and bought more water.
And that's why we ran out of water up there, and I just, yeah.
Go ahead, Bob.
Sorry.
Oh, you're good. You got a comment, go ahead. We're more like such comment. So we'll plan for winter field day. It's not as bad. Usually it's inside here. We throw some antennas outside, we just get on the air. I think we'll just do like 1 or 2 this year. Because last year I think we had 3 and 1 that was never used. If we can get the spider web up, we can do that. Just look for videos, not have any other antennas. Nothing like that. So we can look at that again, because that belongs to the club. Other than that, I think we had a good time. Let's have some more fun. August event, I'm not sure yet what we're gonna do. But I'm thinking I might invite everybody to join me at a park for a club photo one weekend.
Since you mentioned that, you say we still need a program for August?
No,
Oh, okay.
that's the junior DX thing.
All right. Well, I'll throw this out. You and I chatted about this very briefly, but Joe Hawley asked about mesh networks, and I just happened to be talking to somebody about that. So I've been talking to people and trying to educate myself about mesh networks versus the Arden network. And if anybody's interested in that, let me know. If anybody knows about that, let me know. And I got a fella, he presented to the Rat Pack. He's from Philadelphia. He really knows his way around Arden. And that's some cool technology. There's a difference between the two. Arden's kind of like having your own internet. So you set it up and you can have your VoIP phone attached. You can have cameras attached. You can have communications devices attached. And then the mesh is, we sort of know what that is, where, everybody's part of the infrastructure. So I'm trying to learn more about that and find a presenter. And when it comes down to it, it might be for LARC and BARC and BCARES and Northern Colorado. I don't know if we're, do it all separately or together, but right now I'm trying to figure out how to ask the correct questions to get the presentation put together that we want.
And Bob, I think we have October, November still open.
Okay. So I told him it would be later in the year. I had one guy step right up and, I'll talk to your group. I just want to make sure that I'm answering the right questions first. So if anybody wants to help me brainstorm that, drop me a line.
Okay. Probably either October or November. If you said do November, what I was thinking of doing October is I wanted to have a presentation and bring in all the club's equipment, all the radios. We go through it, we hook them up to an antenna, we test it. That way we're ready to go on field day. That's the one thing we didn't do with field day this year. That's a learning experiences. We had complaints about one of the icons supposedly not pushing on a POW. Okay. Bob kind of tested it, didn't have a power meter, but did you make any contacts with it, Bob, or no?
Well, I was looking at the current demand
Okay.
and comparing that with my 7300.
Okay.
And it was on the sideband, it was way down compared to the 7300.
And it's possible it's got a bad something in there or whatever. But we need to start testing our equipment more often because it sits in my basement otherwise, unless people check it out. That's why I'm hoping to start promoting Go boxes next year and equipment that the club has. Don't use it. Belongs to the club, you're a club member, right? Hell, I use it sometimes myself at home, but it's available to the club. So I'm hoping the 891, when I get that Go box built, will be popular for POTUS because it should be one case, not like our big Go box where it's 2 cases and it weighs like 150 pounds. One case, you pick it up, throw it in your vehicle, go drive it apart, put it on a bench, you're up and running in a matter of 5 to 10 minutes. This is the concept. The antenna I'm going to get with it is really neat. It's called the JPC-12. It's a vertical multi-band, bottom-fed center coil. I think it's a 19-footer or 23-footer total. And with the radios, if you get them done just right and you get the coil just right, it'll do 1-to-1 on 20 meters. Every time.
Wow.
I've had 1-to-1 20 meters. On average, 1-to-3 on 40.
How much does that run? How much does that cost?
About $149 on Amazon.
Really?
Yeah, and it's a small little black carrying case. And the plan is to actually make sure it fits in the case with the radio. So then all you do is carry one case. So for example, the satellite radio, we actually have two cases with it because you have an arrow antenna with it. That just doesn't fit into a case. There's no way to make those fit into a case. But Chuck Lucas, who put it together for us, built a nice case to carry it in. And it's almost like a quiver type scenario with the arrow antennas on it, and it plugs in, and you can just take them and put it apart. Really kind of neat. So if you're interested in checking those out, keep an eye on the website. I'll send an email once available. I'm in the process of putting it into our inventory database right now. It's on the web, and then you'll be able to check it out through there. So keep an eye out for that. If you're interested prior to that, and you're attending the meeting, drop me a line. Yeah, Chuck. Yeah, I want to check that stuff out. What do I do? Okay. We used to require a test for the 7300 and V710GA. I think we're going to get rid of that test. And if you want to go play with it, we have it set up that you can just restore it from the SD card. We do ask, of course, against club equipment, treat as such. Be careful with the antennas and make sure you use the proper power on it. They've already had one incident where we had a woofer recoiled. Somebody did digital on 100 watts, and it now looks a little bit. But he did replace it with a club. And I keep it in a box as kind of a showcase. It's kind of neat. It's kind of cool to watch how they can make a coil bend with 100 watts of RF. But things like that. And I think we just need to start getting the equipment used more often. That, and to be honest, I'm tired of it sitting in my basement. So, but if you have an idea for a go box, please let me know as well. The club is not hurting by any means. And if we can put go boxes and people join just to use a go box, I'm all for that. You know what I mean? And use it. Go out, enjoy it. Get on the air. We've got the woofer recoil for the big go box, this little portable one for the POTA go box. The satellite's got the aero antenna and the DMR go box on the hotspot. And a Kimwood the satellite's a D72, anytone in the DMR. So we got some decent radios in there. And most of them are programming. You play with programming, add to it, take away, whatever you want to do to help the club. If you check it out, you're more than welcome. Okay. So thank you, everyone. Have a great evening. And I appreciate you participating. And we'll see you next month.
Very good. Thanks.
Thanks.
Good meeting. Thanks.
Thanks, everybody. Couple of quick announcements. We had a silent key who donated a FT5000 to the club. It's a 200-watt radio. It's more for DX and contesting. We're never going to use it as a club. The board has approved the sale of it. I did find a buyer for it. I'll be delivering it tomorrow. And then what we're going to do is take those funds and turn around and buy equipment for other go boxes for the club. I haven't set it up yet, but currently the club has, and you'll be able to check out as a club member, a DMR go box, a satellite go box. We have the regular go box with the 7300 and the 710GA. And then we're going to build a POTA go box with a Yaesu 891 with an antenna, battery, ready to go, portable, small, lightweight, take it, go activate a park. There'll be a form online where you can check it out. Take it for a couple of days, a week, let us know. And then I will store it at my place and I'll make arrangements for you to come pick it up if you want to check it out. So one of the things that at the board level, we've been talking about doing is how do we do something different as a club? This is what we're doing. We're offering equipment for you to check out as part of your membership. Okay. So you get some tangible, you can try before you buy. Let's face it, radio equipment's not cheap. It's going to probably even get more expensive here in the next month or so. So use what we have. We have a couple of icons that will be available for checkout as well. We've had some issues with them at field day, so we're looking at those as well. Possibly replace them, or if you want to play with them, you're more than welcome to check it out. But I'm going to have everything online that you can check out that's available. The other thing with this purchase, reinvestment of funds, is the club's going to be buying an antenna analyzer. So if you need to check out your antenna, check the SWR, maybe you think you got a faulty wire somewhere, We're not getting a cheap one, we're getting a good one, because a lot of times those are one-time use, which is set up, they're good, and you never need it again, so people don't invest in it. The club will not have ones you can check out and use. Okay, so keep an eye on that on the website. That will be available in the hope in the next couple of weeks. Okay. Other than that, Steve's looking for volunteers for events for the club this year. We've got several parades. First one's August 7th, in Boulder County.
Second,
That's what I said.
Saturday the 2nd.
Saturday the 2nd of August. So contact Steve Robiano if you're interested in helping with the Boulder County Fair Parade. He's looking for volunteers. I'm looking for volunteers in general for the club. So if you're looking to help out, please let me know. Like I told the board, it takes a village to run this club, not an individual. And we have a lot of little individuals that are running it. And I'm not going to speak for them, I'll speak for myself. Chuck's getting really tired, but I don't mind doing it as long as I have the cycles. But there's sometimes I just don't have the cycles to do everything, so I need help. With that said, I've decided I'm going to run again for another year.
Yay.
So I think the elections, if I remember by the bylaws, are September. So I will run again in September. If anybody would like to run for a position or run against me, please. I love competition. Bring it on. Let's get people. If you want to get on the board, learn more about the board, contact a board member, and we'll be more than happy to share those thoughts and ideas with you. Try to keep an eye on time here so we can run outside and do this. Let's see what else is going on. There's a test session at the end of the month here at the Clover Building at 9 a.m. 9 a.m. It's a PVED, so it's free. Come on out, get your ticket, upgrade, things like that. Yes, Bob, I'm going to bring that up next. Thank you. So if you need a grant, you're a general expert technician, somebody wants to test. Hopefully, I got one guy I know is going to come out and test. Finally, field day blew it off. Come on out, get your ticket upgrade, things like that. It's all electronic, it's free, except for the $35 from the FCC. So it's a little bit of fun. Another big announcement, we desperately need another Aries representative for the club. We are one of the founding members of the Boulder County Broomfield BCARES, or amateur radio emergency services. We usually have two representatives. One of our representatives stepped down. Bob Smith is currently the only one that's on there. He needs help with that. As a secondary or primary position, you can alternate however you guys want to do it, or gals, but we're looking for volunteers to help with that. So if you're interested in that, please contact Mr. Smith, N0OW or OM, and he can give you more information, or you can contact me and I'll redirect you as well. I did put that in the last one of my emails, so check my emails for information on that as well. There's several events throughout the state of Colorado that they're looking for volunteers and help on that I've been sending out. We got the borough races, I believe last weekend or this weekend is the charity bike race, the classic bike race. So keep an eye on for newsletters that I send out because there's a lot of things going on. We are going to try to do winter field day again. I'm thinking might be like we did last year. We'll just use this room, go for 4 or 5 hours. Otherwise, it gets cold, miserable, and people get cranky. And then maybe work with Doug Sharp, and Pam usually does it as well. Maybe join there and do it as a joint venture like last year. Let's see what else is going on and things that I need to announce. Overall, the club's doing very well. We do have a good membership base and everything's good with that as well. So really quick, we got 4 minutes. Steve, K0STE, anything from your side of the membership?
Nothing tonight.
Thank you, sir. Bob, Whiskey Alpha Zero, Julie J. Charlie, our treasurer, anything for us?
No, we're in good shape financially.
Okay, good. So Robiano, our director at large.
Just the two immediate events that we have coming up. One being the Boulder County Fair Parade in downtown Longmont. That is on Saturday, the 2nd of August. And then also we have the Longmont Triathlon, easy for me to say. And that is on the 16th, Saturday, 16th. And I will be sending out an email to the mailing list.
Okay. So look out for an email from Steve looking for help volunteers for that. Education chair. Brian, anything?
Test sessions.
Okay. There's also a ham fest at the Adams County Fairgrounds the third Saturday or Sunday in August, or is it before? Yeah, there's one at the Adams County Fairground that's Armed Hams Ham Fest on a Sunday, so basically come out and look for that. Little change, really quick, also is August. We were going to do an outside presentation in August with the spiderweb antenna that the club owns and set it up, play with it, show how you can do 3 radios on 1 antenna. Pretty slick. But we're going to postpone that in September. The reason being is I'm part of the Mile High DX Club as well. And we had our picnic this week. And we had a college student. She's a junior DXer. And she goes on the expeditions. She's doing 2. And she wants to present on what they do. And when I say junior, I'm talking like 25 and under that are going on these expeditions. And she's also, of course, trying to do it as a fundraiser as well and trying to look for some help with that. So I'm going to have her come in and she's going to do August because her first thing is, I think, September, October. So that'll give her a chance if people want to help her out, we can do that for her. Okay. So that should be an interesting presentation. I didn't know there was a junior DX group. And I just found that fascinating as all get out. And we talked for like almost 2 hours. She's also a pilot, which is cool. And then in September, we'll do the outside, we'll do a barbecue. So we'll eat outside, we'll put a cobweb antenna up, I'll bring a couple of radios, we'll hook them up, and we'll try to make some contacts on different bands on the same antenna. So mark your calendars for that, should be fun. If it's raining, then we'll come up with a plan B. And then we have a presentation, I believe, from Edge of Space Sciences, possibly in October. I need confirmation on that. So we still need one for November. And then December will be the Christmas party. Christmas party this year is going to be a little bit different. It's usually reserved for members only. This year, we're opening up to anybody who subscribes to our website and our newsletter. Okay. The reason I'm doing that is I feel that maybe we get more people to come in and join us. The more the merrier. We have a lot of fun. I mean, last year, for some reason people raved about my Christmas party event. I don't know why, but I got to come up with something different for this year. But it's usually a good time, socialization, meet somebody new, bring your spouse, whatever. So the plan this year is we're going to open up to everybody, and then basically, we can only have a max amount, but we never usually hit that. I think if we invite everybody, we might actually be close to that max amount and have even more fun. So I'm opening up to everybody. So if you know somebody that like to come out and socialize, we get to know ham radio or whatever, then kind of go from there. It's 9:12. We're going to take about a 10-minute break really quick. We're going to go see if we can get some pictures from the ISS. For those of you online, go out and grab your radios at 145.8. Let's go see if we can go get a sound.